Hi, I'm Rob and welcome to this, our 11th lesson in the topic of trigonometry. And having dealt a little bit with working with radians in the previous lesson, in this lesson we're going to have a look at finding the length of an arc. Okay? So, if remember, an arc is part of the circumference of a circle. So if I take a circle like this, if I pick 2 points on the circumference, if I pick that point there and that point there, an arc is this, that's the part of the circumference of the circle that lies in between those 2 points. So that's the arc there. There's also an arc on this side, of course. There's 2 different arcs there. This one here is what's called the minor arc. It's the smaller one. And this one out here is the major arc. The 2 of those together make up the circumference of the circle. And it'll be very clear from the phrasing of any question which arc you're dealing with. All right? So the key idea is that that's the arc there. To find the length of that red line, which we call L, the length of the arc, the 2 measurements I need are, first of all, if I join the 2 endpoints to the center of the circle like that, that angle there, theta, the angle at the center underneath the arc there is a measurement I need, and I also need the radius. So any arc is defined by the angle it creates at the center of the circle and the radius of that circle, right? And there are 2 different formulas for finding the length of an arc, depending on whether this angle here is measured in degrees or radians. And we mentioned the previous lesson when that might be the case, that maybe if we're dealing with something that's in motion in a circle here, we might maybe measure theta in radians. If we're dealing with a static diagram where nothing's moving, we may use degrees, but it doesn't really make any difference. There's 2 different formulas for finding the length of an arc. One of them is this, okay, it's theta over 360, okay, multiplied by 2 pi r. Now, that's the formula we use when theta is in degrees. Okay, and you can maybe see how that formula works. Because remember, this part of the formula here, 2 pi r, that's the circumference of the entire circle. That's the length of that full line from here all the way around. That's 2 pi r, the circumference of the entire circle. And by putting this angle theta over 360, we're working out what fraction of a circle this is. So we say, let's find the full circumference, and then we multiply that by whatever fraction of a circle we're dealing with here by putting that angle over 360. So that's one formula if it's in degrees. If it's in radians, remember, it's much simpler. It's just r times theta. Now, if you remember the definition for radians, that the radian measurement of an angle is just the length of the arc divided by the length of the radius. So to find that angle there in radians, it would just be theta is equal to L divided by r. Take the length of the arc and divide it by the radius, and that tells you how many radians the angle is. So if you multiply both sides there by r, like that, you get r theta is equal to L. Okay, just this formula here. Okay, so it's much easier to work with, and in this case, that's when theta is in radians, right? And just to remind you that those 2 formulas are also in the state exams formula booklet. So you can see again on page 9, the same formula, the same page we were dealing with back in lesson 9, we were dealing with the area of a triangle. So you can see your area of a triangle formulas are the ones that are down here at the bottom of page 9. But if you look at the top half of page 9 there's your 2 formulas for finding the length of an arc. Okay, so the 2 formulas that we just mentioned there, you can see there's your 2 pi r times theta over 360, and that you can see is when theta is in degrees. We've got the reminder here, and there's r theta there, and that's when theta is in radians. So there's a very clear reminder there on page 9 which the 2 formulas should be using. So they're both there depending on what unit of measurement is used for the angles. If you look then at the questions on page 145, the first one there you can see we've got this curved line here. Right, so we're asked to find that curved line there, that arc there, and we're told that this is 4.5. Okay, that's the radius because we're told that 0 is the center, which means this is a radius here. And the angle at the center is 80 degrees. So because the angle is in degrees, we'll just use the degree version of the formula. Theta over 360 times 2 pi r. So the length of the arc there, it's theta over 360, it's 80 over 360, okay, multiplied by 2 pi r, 2 pi times 4.5. I just put that straight into my calculator, and if I do that, it comes out at 2 pi. So remember that unless he tells me to give it to decimal places, I leave it like that. Okay, giving your answer in terms of pi is the best answer. In this case, he's actually asked me to give my answer in terms of pi, so I'll do that anyway. So the length that is there is 2 pi, and again, because there's no unit of measurement given for the radius, there's no unit of measurement given here. So if that was in centimeters, then so is this, because it's a length. It's the length of that curved line there. So whatever the unit of measurement is for the radius, the unit of measurement will be the same for the length of the arc. So you can see that in question 2 on the same page. Again, we've got another arc to find the length of here. All right, you can see that the angle at the center this time is 49 degrees, again because 0 or sorry, O is the center. We're told that in the question, all right? And this time the radius is 20. So again, because the angle's in degrees, same formula. It's just theta over 360. So it's 49 over 360, all right? Times 2 pi, or 2 pi times 20. So I just put that straight into my calculator, and that comes out as 49. It comes out, remember, as 49 over 9 pi. But as we met before, I would put the pi above the line. That's just a personal preference. 49 pi over 9. And again, no units of measurement here, no units of measurement here. Right? Part 3 then, you can see you've got a larger arc this time. Okay? Like a kind of a stretched Pac-Man there. All right? This time you can see that the angle at the center there is 8 pi over 7. Right? And the radius here is 8.4. Now this time the angle is in radians. How do I know that? It's not just because there's a pi in there. The reason I know that's in radians is because there's no degree symbol. So in the previous one you can see the degree symbol here indicates that it's in degrees. There's no degree symbol, it's a radian measure. Okay, it's the only other measurement it could be. So that's a radian measure because there's no degree symbol. So I'm going to use the formula, just or times theta. So when it's in radians, it's very simple, you just multiply the radius by the angle. So it's 8.4 times 8 pi over 7. So or theta, just multiply the angle and the radius together when the angle's in radians, and that comes out at 48 pi over 5. And the last one, the same page, same basic idea. Okay, we're asked to find the length of an arc like that the angle at the center is 7 pi over 12. Again, that's a radian measure because there's no degree symbol. The radius is 5.4. So to get, because again, O is a center, we're told that. So I know that's a radius because that's the center. I'm told that's a center, and I'm told that's a center, so I know that's a radius as well. If that's not the center, then that's not a radius. Okay, so it's important we know that's the center. All right. So again, the length then is just the radius 5.4 times the angle 7 pi over 12. And if I pop that into my calculator, that comes out as 63 pi over 20. And none of those answers have units of measurement because the radii had no units of measurement either. So in the two questions on page 146, which look like this, it says find the length of the radius or in each of the following diagrams. It says O is the center of the arc in each case. So again, in both cases that O is the center of the arc, that's important because that means that the angle of the center means that this here is a radius. All right. It says give your answers correct to one decimal place where relevant. All right. So if you look at the first one here, that I know the angle, I know the arc here, and I'm trying to find or. So I'll use the version of the formula where the angle's in degrees because it is. So if I was filling out the formula, it's going to be theta over 360. So it's 142 over 360, right? Put the angle over 360 times 2 pi or times 2 pi or. I don't know what or is, but I know that should equal 31. So I set the equation up like that. So I know what theta is. I don't know what or is, but I know what the answer should be here. So what I'll do first here maybe is I'll just multiply both sides by 360. Okay, so if I just multiply both sides here by 360, I'll multiply that side by 360 and that side by 360, all right, because they'll cancel. And then 142 by 2 pi or, that's 284 pi or. Okay, on this side here. And then 31 times 360 is 11160. All right, and then I just divide across by this to leave or by itself. So divide 11160 by 284 pi, and or comes out there at about 12.5. And remember, because L was given here as 31 centimeters, the radius will have the same units, so the radius there is going to be 12.5 centimeters. So I fill the formula in and then solve for the letter that I don't know. Okay, so the same with this one here. I'm asked to find the value of or here, so I'm asked to find the radius. Or I know the angle is pi over 5. Remember, that's a radian measure because there's no degree symbol in there. And we know the length of the radius is, the length of the arc is 1.6 pi centimeters. So again, remember, I'll use the version of the formula where the angle's in radians, so it's just or theta. So multiplying or by the angle will give me the length here, so just or times pi over 5 will equal 1.6 pi. So again, if I multiply both sides by 5, to remove the fractions, as usual, I get pi or is equal to 1.6 pi by 5 is 8 pi. And you can cancel the pi's on both sides, or is equal to 8. And again, don't forget your units there, centimeters, because the arc length was given in centimeters, that means that the radius is in centimeters as well. And then finally, the two questions on page 147. Having done a couple of questions where we work backwards to find the length of the radius, just as easy to work backwards to find the size of the angle. It's very easy to do that in radians. Now I was trying to find the size of the angle in radians. Remember, all I would do is just divide this by this. That's the definition of radian measure. Okay, so just divide the arc length by the radius and you've got the unit of you've got the angle in radians. No real calculation there necessary at all. But I'm trying to find it in degrees. So question 11.3 on page 147 says find the measure of the angle at the center, theta, in each of the following diagrams. Again, O is a center in both cases. Okay, which means that these two measurements here are radii. All right, it says give your answers in degrees correct to 1 decimal place. So if I was asked to find that one in radians, it'd be no problem. 11 centimeters divided by 12 centimeters, that's just 11 over 12. Okay, so that's the radian measure of that angle there. Remember, the centimeters will cancel, so your answer is no units. So the radian measure of that angle there is 11 over 12. Arc length divided by radius length. And the radian measure of this would just be 16 over 7.5. Again, units of measurement, there aren't any, but they would cancel. So radians have no units of measurement. But to find them in degrees, again, remember that the formula is going to be theta over 360. Because I don't know what theta is, times 2 pi or. And or in this case is 12. So I don't know what theta is, but I do know what or is, and I know the answer there should be 11. And now we'll just solve for theta. Okay? So to get rid of the fraction there first, I'll just maybe multiply. Anytime I see fractions, as we met before, I just multiply both sides by the denominator to get rid of that, because they'll cancel here, and I just get what 24 pi times theta there is equal to 11 times 360 on the right-hand side is 3960. And then just divide by this, divide by 24 pi to the theta by itself. So theta there is 3960 divided by 24 pi, which is about 52.5. And don't forget to put the degree symbol in, because otherwise the implication would be that the answer's in radians. You must include your unit of measurement. And the same with this one here. If I wanted to find the measurement in radians, it would just be 16 divided by 7.5. No problem there. But to find it in degrees, the formula is theta over 360, because I don't know what theta is, times 2 pi or, which is 2 pi times 7.5. And that should equal 16. So again, I'll multiply both sides by 360. Anytime I've got an equation, you can see anything we've done here, anytime I've got an equation in there with a fraction, I'll get rid of the fractions first. And here I get what? 2 pi by 7.5. That's 15 pi times theta is equal to 16 by 360 is 5760. And then divide across by this. So theta is 5760 divided by 15 pi, which is 122.2 degrees, correct to 1 decimal place. So that's how we find the length of an arc, depending on whether the angle is measured in degrees or radians. So in the next lesson, we'll kind of have a quick look at finding the area of a sector, which is very similar to that. So we'll pick it up from there then in our next lesson.